So, hello all. Now we are beginning module 2 and module 2 of this course in fact, and in this module we are going to learn one sample non-parametric test, and under this module the first lecture deals with sign test. Okay. So, first we will see that why one sample non-parametric test. One sample non-parametric test, what does it mean? Why one sample? Okay. So, in this part, as I am saying that the first part is sign test. So, in this lecture we are going to cover the definition of one sample location problem, null and alternative hypothesis, sign test and the properties of sign test, and of course we will be doing few problem solving. One sample non-parametric test. One sample non-parametric test is the testing procedure based on a single sample when the sample does not follow a normal distribution. So, it is based on a single sample. There are few observations x1, x2, xn, and on the basis of this observation we want to make some test related to, say, the measure of central tendency, measure of location, measure of scale, measure of skewness, like this. So, that is why it is called one sample test, and when your methodology used to address this test is non-parametric way, then we are having one sample non-parametric test. Under one sample non-parametric test, there are generally two types of problems. One is one sample location problem, another is one sample scale problem. One sample location problem means test for the location parameter based on a single sample. What is a location parameter? The parameter which talks about the central tendency of a probability distribution, that is called the location. That means we are trying to figure out the center of the distribution. Distribution here means the data distribution, the center, okay, the central value of the data distribution. Now, as you know, most widely used location parameters are mean, median, mode, but when you are dealing the problem from the perspective of non-parametric, then we have to look for rank based measure. What is the rank based measure here? Of course, median. Okay. So, now we are beginning one sample location problem. Later on we will study one sample scale problem as well. One sample location test checks whether a location parameter differs from a specified value. One sample non-parametric location testing problem checks on the hypothesis adopting a non-parametric technique, and that is why it is called one sample non-parametric location problem. Clear? In one sample non-parametric location test, the parameter under study is population quantile. One particular case, as I have told you earlier, is median. Similarly, one can think of any quantile, any quartile, any percentile, decile. We will see what are those terms, what they mean for. As for skewed non-normal data, quantiles are more robust than mean. Also for ordinal data, quantiles are more meaningful. So, see, in one sample location problem, we are not using mean, our very common measures of central tendency, that is the arithmetic mean, geometric mean, harmonic mean. We are not making any test based on the mean, rather we are restricting our attention to the rank based statistic as quantile, quartile in specific. Okay. Usually one sample location test is based on population median as a substitute of population mean. What is a quantile? Pth quantile of a distribution is a value that divides the distribution into two parts, where lower part contains p proportion of distribution and upper part contains 1 minus p proportion, and that is what is called pth quantile. In terms of data, pth quantile is a value below which p% of the sample observation lies and above which 1 minus p% of the sample observation lies. Personally speaking, I think this expression, this definition in terms of data will be more understandable to the people who are learning quantile, learning the concept of quantile for the first time. Quantiles have some particular case. Most particular case of quantile is quartiles. In quartiles, the entire data is being split by 4 parts. Okay? So, there are 4 equal parts and each part is demarcated by first quartile, second quartile, Q3 and Q4. Okay? So, Q4 is the maximum. Q4 means total is n. So, the Q4 is nth observation. We will see. I have written here Q4, but there are in general there are only 3, first quartile, second quartile and third quartile, and Q4 this is the maximum observation, largest observation, nth observation. Okay? So, similarly decile, when you are considering decile, decile makes the entire observations into 10 equal parts, and similarly percentile, which makes the entire zone of observation in 100 equal parts. Okay. You can see that this is the entire, I have written Q4 here, this is the entire zone of the observation. So, how many total observations you have? You have say n observations. So, quartile means you are splitting these n observations into 4 equal parts. So, this part is n by 4. So, this is the lowest value, minimum value, this is the highest value. Remember, you have the observations like that, x1, x2, xn. Suppose your lowest value is x1 and suppose your largest figure, largest observation is xn. So, what you can do? You can just take x1 here and Q4, which is the largest observation, clear, and in between you are splitting the entire n, capital N, into 4 equal parts. So, this is part number 1, this is part number 2, this is part number 3 and this is part number 4, n by 4, n by 4, n by 4, n by 4, and Q1 is the first quartile, Q2 is the second quartile and the third quartile is Q3. Okay, Q4 is itself the highest value. So, even if I am writing fourth quartile, that means it matches with the highest value, clear. So, median is the middlemost value above which half of the observation lies. So, if I restrict Q2, how many observations lies above Q2? N by 4 plus n by 4. So, half n by 4 plus n by 4, altogether it sums as n by 2. So, n by 2 observation will be above this point and n by 2 observation will be below this point, and median, that is why median is called middlemost value. Similarly, so in a nutshell what I can do, that median is the point which divide the entire n into 2 parts. Above the median n by 2 observations lies, below the median n by 2 observation lies, and probably you have noticed that Q2 is analogous with the median. Why? Because above Q2 n by 2 observations and below Q2 also n by 2 observations. Just add n by 4 plus n by 4, what does it sum up? It sum up as n by 2, clear? So, finding the median, I know all of you are familiar with the process, mathematical procedure of finding median. Let us have a quick recapitulation. Arrange n measurements from smallest to largest, that is essential. If your n is odd, m is just the middle number. If your n is even, m is the average of the middle two number. Average means arithmetic average of the middle two numbers. For the sake of your convenience, here I have taken one example. It's a very simple example. The observations are like that: 3, 5, 0, 1, 9, 2, 7, 10. So, how many observations are there? 8 observations are there. So, first you have to arrange the data 0, 1, 2, 3, 5, 7, 9, 10, and since n is in even, so you can just split into two halves, 8 by 2 and 8 by 2, so 4. So, median will be one place below which 4 observations lie and above which 4 observations lie. So, this position is meant for median. You can see I am making one red circle. So, since this position is vacant, because we have 3 or we have to take 5, then what will be the responsible figure which we can look as the median? So, the basic technique is just take 3 and 5 both, make their average, and that will be your median. So, in this case 4 is your median. If I ask you what is the first quartile, look at the picture. First quartile Q1 means below Q1 there will be n by 4 observation, and above Q1 there will be 3n by 4 observation. So, n is your total number of observation, which is 8. 8 divided by 4, that means 2. So, you can see n by 4th observation, 8 by 4th observation. So, which one is the second observation? That will be your first quartile, right? The second observation in this arranged sequence is 0, 1. So, 1 is the second observation. So, 1 is your Q1. Similarly, you can find out Q3, the third quartile I mean to say, that is 3n by 4th observation, that means the 6th observation. Okay, you just make the replacement of n by 8. So, 3 into 8 divided by 4. So, 6th observation. Count the 6th observation in this sequence: 1, 2, 3, 4, 5, 6. So, 7 has the rank 6. So, 7 will be your third quartile. Probably you have seen that all these quantiles, no matter what it is, might be it is median, might be it is first quartile, third quartile, all of them are based on the relative position of the data observations, right. So, that is why they are rank based. Now, you can use R code for finding out median or any quantile. I am not going to show it because it is pretty easy, and I hope that all of you can do on your own. So, suppose you have one sequence of observation x3, 5.5, 9.6 and so and so. So, the R code for this, you see median, directly you just write median of x3 and that will give you back with the median. But for quartile, third quartile, percentile, whatsoever, so these are all under the banner of quantile. So, you have to mention the proportion, the below proportion. Clear? Means the proportion, if it is first quartile Q1, so the proportion below the first quartile. Clear? So, quantile of x3, that means out of these observations which one will be the first quartile, and for first quartile the probability below the first quartile is n by 4. So, n by 4 means the probability is 1 by 4 and that is 0.25. So, that is what I am writing here, 0.25. So, for the third quartile it will be 0.75. For the 70th percentile, what is the meaning of percentile? Percentile means you are splitting the entire data into 100 equal parts, okay, 100 equal parts. So, if I am writing it as say percentile 70th percentile, let me write it as P70, that means the probability below P70 is 0.70 and above P70 is 0.30, so that the total probability is 1. So, I am saying it in terms of probability, anyone can think in terms of the sample points also. So, 70% of your total data will be falling under P70, clear. So, that is what you have to mention in our code, that x3 comma 0.70, and R will get you back with the required result. Remember, when I am saying 70th percentile, that does not mean 0.7, it is a number which acquires the position below of that position, probability of falling is 0.7, and above of this position, probability of falling is 0.3, and we are looking for that number, okay, not at the position. Our answer will be in the number. Okay, let us begin sign test, because sign test is closely connected with quantile as well as median, as well as quartile. We have to know the clear-cut idea regarding that quartile. So, sign test is the simplest non-parametric test of location. Now, in which situation we will use sign test? What will be the hypothesis? That is what our context right now. Let the population from where the sample collected is a continuous distribution. My dear student, you have to remember these assumptions. Probably you remember at the beginning of our course, I told you only one assumption is a must assumption in non-parametric test of hypothesis, that is, all the observations are coming from continuous distribution, nothing else. In case you miss this assumption before processing your testing of hypothesis, then that will not bear any statistical meaning. So, do not forget to mention this, that the sample collected, that population is a continuous population, or the distribution is continuous. Let mu be the median, the probability or the chance of observation falling left to mu and the probability or the chance of falling right to mu is equal, and that equals half. That is the definition of median. The probability of observation, let me name that observation by x, less than mu is equal to probability x greater than mu, and that is equal to half when you are selecting mu as your median. Clear? Let x1, x2, xn be a random sample from this distribution. Suppose under the null hypothesis you know a specified value of mu, and that is say mu 0. Mu 0 can be anything, mu 0 can be 4, mu 0 can be 5. You are assuming that this is the specified value of the median of that data under the null hypothesis. Now, h1 mu greater than mu 0 or h1 mu less than mu 0, it should be mu less than, I am really sorry for this typographical mistake, mu less than mu 0 or h1 mu not equal to mu 0. So, three types of alternative, as we know quite well, we can address with this sign test. If the sample comes from the distribution with mu 0, we expect half of the observations will be greater than mu 0 and half smaller. So, when I am tagging the under null hypothesis, the median is mu 0, that means half of the observation will be above mu 0 and half of the observations will be below mu 0, right from the definition of median. Replace each greater observation by a plus sign and the smaller observation by a minus sign. So, when I am saying greater observation, what does it mean? Greater observation means the observation which is bigger than mu 0, and observation which is smaller than mu 0, that is the lower observation, okay, or smaller observation. Count the number of plus sign, and we know that is, or we denote this part as r, small r, and number of minus sign is small s. Okay. So, under null hypothesis, these r follows a binomial distribution. Why? Because we know null hypothesis mu 0 is the median. So, probability of having plus sign should be half of the total observation, right, and probability of having minus sign should be half of the total observation, because we have chosen mu 0 as our median. Clear? So, under null hypothesis, these r follows a binomial distribution with parameter n, total number of observation or total number of sample points you have taken is n, x 1, x 2, x n, and the probability of success of that binomial is half. Why? Because it is a median. X greater than mu 0 is half, and x less than mu 0, that is also half. So, binomial with success probability half. Therefore, this structure H naught is equal H naught mu is equal to mu 0 against these alternative can be rewritten in the form of the probability as well. H naught p is equal to half against H 1 p greater than half or p less than half or p not equal to half. Now, you can ask me that what this p stands for. P stands for that probability x greater than mu, that is equal to p. Okay, that is p. Why? And what is that mu? That mu is under null hypothesis mu 0, it will be equal to half, and under alternative hypothesis this will be just p. Is it clear? When we are choosing this mu as mu 0, then that p will be half, and when this mu is not equal to mu 0, then that p will be less than half or greater than half. So, whatsoever that p is not equal to half, that will be the stuff. Okay. Now, the rejection strategy. So, what is our test statistic? If I ask you that what is the test statistic here, the test statistic is number of plus sign. You see why it is a non-parametric test? Because we do not know the parent population structure from where you have chosen x 1, x 2, x n, but we have defined a new distribution, we have derived a new distribution for x 1, x 2, x n. Clear? So, that is why it is non-parametric. Okay. What is the rejection strategy? How do you reject the null hypothesis? For the alternative hypothesis mu greater than mu 0, number of positive signs are expected to be higher when your median is falling. Suppose your median is somewhere here, mu 0 is there, and under the alternative hypothesis you are claiming that median is shifted to the right 2 of mu 0. What will you expect? You expect that number of positive figures will be higher. So, the rejection region will be based on this rule that if r means the calculated r, greater than r alpha is the smallest integer satisfying probability r greater than equal to r alpha less than equal to alpha being the level of significance, we reject the null hypothesis. So, r alpha is your critical point. So, look at this binomial structure. Here I have taken n is equal to 10 and probability is of course 0.5 under the null hypothesis. So, for the right tail test, our rejection will be somewhere here, and what is my r alpha? R alpha is that dot. Clear? R alpha is that dot. So, if your r calculated falls inside that rejection zone, you reject the null hypothesis, and if your r is falls inside this acceptance zone is there, then you accept the null hypothesis. Similarly, for h 1 mu less than mu 0, number of positive signs are expected to be lower. So, we reject the null hypothesis if r less than r alpha prime, where r alpha prime is the smallest integer satisfying the probability r less than equal to r alpha prime less than equal to alpha, alpha being the level of significance. One can fix alpha at 0.05 or at 0.01, so on. For H1 mu not equal to mu 0, the rejection will be two sided or equal tailed. We reject the null hypothesis. So, for left tail test, rejection will be from left side, and for right tail test the rejection will be from the right side. So, there are two critical points, one is from the right hand side, another is from left hand side, and we are taking equal tail test. That means the right tail rejection is alpha by 2 and the left tail rejection is also alpha by 2. So, that the total rejection is alpha by 2 plus alpha by 2 alpha. Now, the point is how to find these critical points r alpha by 2 or r alpha by 2 prime. We have to look at the binomial table. Remember, we have already seen that r follows a binomial, or else you can see the r function d binom k n p. So, this is the r function d binom k n p, which calculates the probability of k success in n trials. Think about three arguments: k success, n is the total number of the trials, and p is the probability with success probability p. So, that is the density of the binomial. So, d stands for the density, and p binom k n p calculates the cumulative probability up to k success. That means cumulative probability till the point k. So, probability x less than equal to k. So, I have snapshot these part from my R console just for the sake of your convenience. You can just look at it and you can try on your own. You can see that 4 is the value of k, that means 4 success, and 10 is the total number of trials, and 0.5 is the probability. So, what is the value of d binom? D binom is 0.2050781. That means in statistical language, if I ask you what is probability x is equal to 4, probability x is equal to 4 is 0.2050781. And if I ask you what is probability x less than equal to 4, then you can use p binom, and that is 0.3769 whatsoever 531. So, you have to remember that cumulative concept and the individual probability mass. Remember, for the test on other quantiles like quartile or percentile, null and alternative hypothesis may be changed accordingly. Suppose the question is for a data set with size say n, that Q3, that means the third quartile is 4 against Q3 greater than 4, then how do you proceed? Just like the median, you have to think about the probability. In median, you are choosing probability of success as 0.5 under null hypothesis, right? But when your null hypothesis is on quartile, the probability of success, what will be that? That will be 3/4. Can you see here? Probability of success is 3/4. So, what you need to change? You need to change d binom 4, 10, and in place of that probability 0.5, you have to write 3/4. Clear? Also, I am giving you the binomial table look. This is just an excerpts of binomial table. Can you see these are the n, these are the number of trials, and for each of the number of trials the number of success. So, suppose I am talking about binomial 4. So, how many success one can think of? 4 out of 4 trials, 0 success, 1 success, 2 success, 3 success, and 4 success. And look at the right part of this table, you will find the probability of success. So, probability of success is 0.025, probability of success is 0.05, so on and so forth. Now, what does this 0.9163 stands for? This is the cumulative probability. Look at the number of success, that is 2, number of trials, that is 0.4, number of the probability of success, that is 0.3. So, if I ask probability x, number of success less than equal to 2, then you can just make a check, make a cross sectional figure taking 2 and probability is 0.3. But remember, this is all these figures are cumulative probability. Clear? Cumulative probability means up to x is equal to 2, x is equal to 0 plus probability x is equal to 1 plus probability x is equal to 2. Clear? Now, let us have a quick problem solving session, and I hope that this problem solving session will boost up your interest in doing a sign test. Okay, let us read that problem. What does it say? To determine the mileage of a type of truck, 6 trucks were run and the mileage of each obtained with gallon of gasoline was as follows: 21, 19, that means per gallon of gasoline, how much amount of travel one truck can do. So, 21, 19, 22, 18, 21 again. So, repeated observation, mind it. 24. Use the sign test to examine whether the average number of miles run with a gallon of gasoline by the truck of this type is 20 and the alternative hypothesis is greater than 20. So, very clear. So, in this case, in this question, we can see n is equal to 6, very small. So, we have to think of non-parametric test, and what will be our null hypothesis? Our null hypothesis mu is equal to 20 against mu greater than 20. What is mu here? Mu is the median. Clear? Now, sign test, number of observations greater than 20. Greater than 20, look at the trail of observation. 21 is greater than 20, yes. So, assign plus 1. 19 is greater than 20, no. So, that is no, I mean we are not considering that. 22 is greater than 20, yes, 22 is greater than 20. So, assign plus 1 again. So, altogether you will see that 4 observations are greater than 20, right. So, our calculated number of positive signs is 4. Now, fix alpha is equal to 0.05. You have to find out the p value for r greater than equal to 4, or you can make the test in other way round. That means, what will be r alpha, what will be the possible value of r alpha such that probability r greater than equal to r alpha less than equal to 0.05. So, therefore, we have to find r alpha. R alpha is the point where which will be probability r greater than equal to r alpha less than equal to 0.05. So, how to find the r alpha? Either you can go manually or r is there for helping you out. So, we can directly go to our script file and we can write our code and we can find r alpha. Let us see. So, first I have shown you how to calculate manually r alpha. As we have seen that r is binomial 6.5. Why binomial 6.5? Because you remember that we have 6 observations. So, binomial 6 and under null hypothesis probability of falling to the left as well as to the right of median is half. Then the distribution of r is binomial 6.5. Let us use r. R alpha is 6. When you are choosing r alpha as 6, probability r greater than equal to 6. Now, you can ask me that why I am starting from 6? Because it is a right tail test. So, the conventional methodology, conventional strategies start from the largest value of x. What is the largest value of x? Largest value of success in a binomial 6 half experiment, that is 6. So, 6, and now figure out what is probability r greater than equal to 6. R greater than equal to 6, you can use a D binom 6, 6.5. I will ask you to type this code in your R script, and you will find out, after running, you will find out what is the probability value when probability x is equal to 6 with the probability 0.5, that is 0.015625. Okay. So, 0.0156 is less than 0.05, which is our fixed level of significance. That means we are free to incorporate one more point, take another point from the lower side. So, R alpha is equal to 5. So, what is the cumulative probability? That is probability r greater than equal to 5. So, r is equal to 5 plus r is equal to 6. So, that is 0.109. It is greater than 0.05. So, we are surpassing the fixed level of significance. Clear? So, if we surpass the fixed level of alpha, that means we are falling inside the zone of acceptance region. Okay. Remember, the picture is like that. This is your rejection region or critical region, rejection region and critical region. So, when you are choosing R alpha as 6, you are still in the rejection region. Look at the cumulative probability, that is 0.0156. But whenever you are enlarging your rejection region, taking one more value, that is 5, then probability beyond 5 is surpassing your fixed alpha 0.05. Clear? Therefore, R alpha is equal to 6 being the integer for which probability r greater than equal to 6 and which maintains the probability less than alpha. Since r calculated which we have found as 4 less than 6, 4 less than 6. So, we have fixed R alpha as 6. So, beyond which we can say anything will be in the rejection region. Now, look at the position of 4. Position of 4 is to the left of 6, therefore, you are in the acceptance region. That means we fail to reject the null hypothesis as per the value of R calculated. Hence, the average mileage of the truck is 20 miles per gallon of gasoline. So, that will be your final conclusion. The same problem you can achieve by p value calculation. So, what you need to calculate out when you are dealing with p value? Probability r greater than equal to r calculated. So, r calculated you have found as 4, r greater than equal to 4. You can have your R script ready. So, 1 minus p binom 3, 6.5, 3 is your number of successes out of number of failures 6 and probability is 0.5, that is 0.34375. So, this is the p value. Now, you can see that p value is bigger than alpha 0.05, we fail to reject the null hypothesis. So, that is how in sign test you can find out the probability or p value, or you can find out the critical point, and on the basis of either on critical point or on p value you can make the decision. Let us have one quick example. Example 2, a particular brand of TV set uses picture tubes from suppliers if at least 85% of their tubes have a life of at least 600 hours. In a random sample of 20 tubes of supplier A, 16 survived this life test. Should the TV manufacturer purchase this brand of tubes from supplier A? This problem is a slight different problem than the previous one. Why? Because in this problem the number of positive sign, let me tag it as success, is already given. You do not need to count that how many observations are falling to the right of your median or to the left of the median. In fact, in this problem no mention on median is made. It is basically a problem of proportion, problem of probability, but that can be tackled down with the use of sign test. Now, what will be your null hypothesis for this problem? P is equal to 0.85, H1, P less than 0.85. Now, why it is less than? Now, have a check from the question. The question language is extremely important to note down. The question asks that TV manufacturer purchase this brand of tubes from supplier A if at least 85% of their tubes have a life of at least 600 hours. That means probability of success, if it is lower than 0.85, then the TV manufacturer will turn down that proposal. Am I clear? So, probability of success, if we understand that success means that a life of at least 600 hours and failure means a life of less than 600 hours, then if this probability is less than 0.85, then the manufacturer will turn down the proposal. Clear? Now, in this problem R is 16, number of positive signs, because already 16 survives, that means 16 bulbs have the picture tubes with the life more than or at least 600 hours. Clear? So, R is 16, total number of trials are made as 20 because 20 observations are taken. So, what is the p value? P value is probability R less than equal to 16 when the null hypothesis is true. Null hypothesis is true means p is equal to 0.85, and using the binomial code in R, you can see p binom is 16 20.85. 16 means number of success. This is the first argument. The second argument, number of trials, that is 20, and the probability is 0.85 under null hypothesis. So, what is the cumulative probability? R less than equal to 16. The cumulative probability, why less than? Because it is a left tail test. Remember these type of points. When you are testing a left tail test, the critical region will be from the left hand side. Clear? So, that is why less than equal to. If it is greater than 0.85, then we have to take the critical region as per the inequality mentioned in the alternative. Then your critical region will be R greater than 16. Clear? So, that probability, that cumulative probability comes as 0.35227. Now, if you fix your alpha as 0.05, then clear cut this cumulative probability is bigger than 0.05, and that means null hypothesis is accepted. Clear? So, what does it mean by the acceptance or fail to reject the null hypothesis? That TV manufacturer will purchase this brand, because null hypothesis accepted means the probability of success is 0.85. Probability of success is 0.85 means at least 600 hours the lifespan will sustain. Therefore, TV manufacturer will purchase this brand. That will be your final conclusions. Clear? So, that is the stuff of sign test, and in sign test I will ask you write all the code which I have given you in your R script, and you can find out that how binomial probabilities can be used in calculating out the sign test. Thank you.